Okay, in this video, I'm going to go through how we use truth tables to check whether an argument is valid. So we'll start by looking at this argument here. We have two premises and a conclusion. The first premise is if A, then B. The second premise is if B, then C. And the conclusion is if A, then C. Okay, so maybe you can see just by looking at it that this argument is valid. Let's remind ourselves of the definition of valid. So an argument is valid when it is the case that if the premises are true, then the conclusion has to be true. Okay, and remember that in this definition, what we're talking about is just if the premises are true. Then what does that mean for the conclusion? Does the conclusion have to be true, or does it not have to be true? If the conclusion has to be true when the premises are true, then the argument is valid. Okay, and then here we also have another definition, so it's an equivalent definition, just a different way of saying the same thing. An argument is valid if and only if it is impossible for all of the premises to be true and the conclusion to be false. Okay, now back to this. Okay, so again, this argument is valid. I'm just telling you that now. Maybe you can see that it is, but we're going to use a truth table, this truth table here, to check, or we might say verify, that it's valid. Okay, so in this truth table, on the far left here, we have the atomic sentences that show up in the sentences in our argument, so you know how that works. And then on the right here, we have each of the sentences. So first here we have the first premise, A arrow B, the second premise, separated by a comma, B arrow C, the turnstile. So recall that the turnstile separates the premises from the conclusion in an argument when that argument is represented in truth functional logic. And here's our conclusion, A arrow C. Okay, so even though we have three sentences, everything else about the truth table is what you're familiar with. I've filled it in here, except we need to fill in this column right here underneath the turnstile. Okay, so what we care about are lines where all of the premises are true. So let's begin by identifying those lines. So here and here, both premises are true. Here and here, here, and then line 8. Okay, so for an argument to be valid, as we've said, it has to be the case that if the premises are true, then the conclusion has to be true. Okay, so we can check that by, here it's the case that both premises, so line 1, both premises are true. Is the conclusion true? Yes. Okay, so that's a good line. It's getting us on our way to this being a valid argument. Here on line 5, the premises are true. Is the conclusion true? Yes. Okay, so that's also a good line. Line 7, premises are true. Conclusion is true. So that's also a good line. And then line 8, premises are true, and the conclusion is true. Okay, so in every case where all of the premises are true, the conclusion is also true, so this is a valid argument. I mean, of course, we knew that, but this truth table shows us that this is a valid argument. Okay, so just one more thing. We actually do need to fill in these spaces here, so we can just make a note for ourselves. You won't do this in Carnap, but line 1, 5, 7, and 8 are, let's say, our super good lines. Those are the cases where the premises are true and we had to check and we found that the conclusion is also true. On these other lines, the premises are not all true, so it's not violating the definition of valid, so in a sense it doesn't really matter. But we put check marks on these other lines as well. So line 2, one of the premises is false, so that's going to be, that line is fine, get the check. Line 3, the first premise is false. Line 4, the first premise is false. And line 6, the second premise is false. Okay, so in those cases, It's not the case that all of the premises are true, so we don't really care what the case is with the conclusion. It's going to be a good line. There's going to be a line that we put a check underneath the turnstile. All right, let's look at this argument. Okay, so again, let's find the lines where, or it's just going to be one line in this case, where all of the premises are true. Okay, so that's going to be line 2. So when all of the premises are true, is the conclusion also true? No, it's false. Okay, so that's a bad line. Then just to fill in these other spaces under the turnstile, line 1, one of the premises is false, so this line doesn't really matter. We put a check. Line 3, second premise is false, so again, it doesn't matter. We put a check. And then line 4, the first premise is false, so again, it doesn't matter. We put a check. But nevertheless, for this argument, actually I didn't say this, so in this argument here we have, this is premise 1, P or Q, premise 2, separated again by a comma, not Q or turnstile, and then not P. Okay, so for this argument, in our truth table, we have one bad line, line 2, so that means that this argument is not valid. That is this argument here. Premise 1, P or Q. Premise 2, not Q. Conclusion, not P. All right, so here's the moral. Well, we already talked about if it's valid, then when the premises are true, then the conclusion also has to be true. Here's one other thing you should keep in mind. A bad line and an invalid argument happens when the premises are true and the conclusion is false. So anytime we have all of the premises are true and the conclusion is false, that's when we put an X underneath the turnstile. That tells us that's a bad line and the argument is invalid. Every other scenario, premises are true and the conclusion is true, or the premises are not all true, is going to be a good line, or get the check. Okay, I'm going to stop there. Of course, you should read chapter 11 where this is explained, and there's going to be at least a couple other videos, and you have your assignments on Carnet.